Hello guys, welcome back to my channel. Today we have automatic barrier project which opens automatically whenever this ultrasonic sensor detects object in front of it. And a buzzer also beeps which indicates that the object has been detected by this ultrasonic sensor. And why we are going to use this battery in this project, because we will use buzzer and the ultrasonic sensor, so they both will draw a significant amount of current from the Arduino Uno. And the Arduino will not be able to provide sufficient current for the proper working of the servo motor, so that is why we will provide additional power supply to the servo motor. And the reason behind the use of this voltage regulator IC is simple, because this Arduino Uno operates at 5 volt but this battery is of 10 volt. So this voltage regulator IC will step down the voltage from 10 volt to 5 volt, and we can easily input the 5 volt to the Arduino Uno. Now from this image you can see the connection among all the components, but the important connection that I want to tell you is related with this voltage regulator IC. So the left terminal is for the input, middle one is for the ground, and the right one is for the 5 volt output. So place this IC on the breadboard and take out one jumper wire from the input terminal of the IC and connect this another end to the positive terminal of the battery. Now take out one jumper wire for the ground, that means from the middle terminal of the IC, and connect it to the negative terminal of the battery. Now we need one jumper wire for the 5 volt output, right? So this is the 5 volt jumper wire. Now we need to have a common ground between this battery and the Arduino Uno. So for that we need one more jumper wire. Connect one end to the middle terminal of the IC and connect this terminal to the ground of the Arduino, right? And this is the 5 volt pin, so connect this to the V in of the Arduino Uno, and you can see the Arduino is powered on. Now let me explain three kinds of precautions that you must keep in your mind while working with this project. The very first one is you must connect this yellow colored signal wire of the servo to the PWM supported pin on the Arduino and not any other digital pin. I have connected this signal pin to the pin number 9, which is PWM supported. The second one is most of the beginners usually connect the servo to the 5 volt pin of the Arduino, which is not able to provide sufficient current to the servo, right? So you must provide external power supply to the servo using this IC. And the last but not the least is the common ground between this battery and the Arduino. Okay, because if you don't provide the common ground between both of these, either your ultrasonic sensor won't give proper reading or your servo won't rotate, right? So these kind of problem may happen if you don't provide common ground between both of them. Now you can also use LEDs instead of this buzzer, as I am using green and red LEDs in the circuit. So red LED is for the indication that no object is detected, and green LED is for the indication that the object has been detected, right? So if you are enjoying this video, hit the subscribe button and share this video to get more such kind of project in future as well. Now let's have a look at the program of this project. So we are importing servo.h library, and in this line we are defining one servo object. And for the ultrasonic sensor, trig pin is connected to 7 and echo pin is connected to pin number 6 and buzzer is connected to pin number 13. And for the calculation of the distance, we are defining two variables, distance and duration. And in the setup function, the trig pin and the buzzer pin are going to be output and echo pin is going to be input. And the servo is connected to pin number 9, and please note that this pin should be PWM supported. Now let us move on to the loop section. So in the first line of the loop section, we are writing low signal on the trig pin, because sometimes due to electrical noise and also due to previous loop iterations, this trig pin remains in high position. So we are writing the low signal and clearing that buffer high signal on the trig pin, right? And in these three lines, we have started calculating the distance measured by the ultrasonic sensor. And pulse-in is a function which returns the time duration it takes for the ultrasonic waves to emit from the ultrasonic sensor and get reflected away from the object, right? And this duration will be in microseconds. So the speed of sound will be this much, right, in centimeter per second. So we need to divide this value by 1 million, right? So that is why we are getting here 0.0342. Okay. And after all this calculation, we are making use of this distance variable. So if the distance is greater than 0 and less than 5, we are rotating the servo at 90 degree. That means the barrier will open and also the buzzer will beep. Otherwise, the servo will rotate as 0 degree and the buzzer will also be off. So if you enjoyed this video, subscribe to my channel and like this video, and also write your review regarding this project in the comment section, and thanks for watching this video.